Hello everyone around the world, Zimbabwe, South Africa, India, all over the world. I can't mention you or you are too many. So let's fix something. We have this phone. This is the Samsung Galaxy A20 which came in for repair. And what is the problem with this phone? Let me show you the problem with this phone. You see here on top, we have the USB power meter, we have the power supply, and we have the multimeter at the bottom. So what I did, I set the power supply to 5 volts, and here we have the USB power meter, type C. So what I'll do, I'll plug in the USB power meter, and it's taking 499 milliamps, which is some kind of bit low. We have this sign. Let's just wait. It's going back to 17 milliamps, and we have charging error sign. That's the problem with this phone. So what kind of problem is this? Charging error sign. You can see the charging error sign on the screen. That's the problem with this Samsung Galaxy A20. Let me test with a different charger. We have this charger. It's a different charger. It's not the power supply. Let's just wait here. Maybe it is the charger problem. Same issue, you see? So it's not the charger. So before we fix this phone, you know what? Let's go back in time. When people they are commenting from the channel, I can see some kind of comments which needs response, or some kind of comments which doesn't need response. I have some comments on the last, if you remember that solar charge controller, you remember that video? Let me show you if I can. Desktop. Yeah, that's the channel BST African Electronic Surgery with 2.3 subscribers. The channel is growing fast. I really appreciate to all the subscribers around the world. Thank you so much. We have this video, solar charger controller. Yeah, circuit board repair with 325 views. This problem, this charger controller, we fix it, but people commented a lot about this. If you check here, that's the video. I opened this thing. And after opening, what did we found? I found that there were some blown up components inside. Okay, go back. Yeah, here. Let's stop here. There was this capacitor. There was another. On the middle was the diode which was shorted. This capacitor was shorted. And here was the resistor. If you see this PCB board, everything is written on the board. You can see here it's the C12, that the value, that the capacitor here. Here we have ZT1, this is a diode, and here we have R39. And let's go to comments. What did people say? The PCB looks bent outside, and you need to scrape the PCB to clean it to prevent electrical leakage. I have done that off camera. The resistor is 221, which is 220 ohms. Where is this 221 coming from? I don't understand. He is not only the person that commented. We have this comment. We have another comment. The value of the resistor is 221. We have about 3 comments. The value of this resistor, you can see this resistor code, which is on the PCB, is R39. That was the resistor code. R39 was the resistor code. And if you go on Google, 3-digit SMD resistor examples, code value of the resistor. Let's go to wave R10, R39. We need R39. This one. If I can highlight it. No, maybe I can't. Maybe I can't. But R39 was the value of that resistor. No, I can't highlight the resistor. But R39 is supposed to be 0.39 ohms. According to Google, it's not 221 ohms. That was not true. But that was a very low ohms resistor. That resistor was a very low ohms resistor. You remember these modern electronics, they are using like you find some fuses like black fuse like resistors. This resistor, yeah, someone asked me, can you have a bend resistor or like a shorted resistor? It's rare, but yeah, it can happen. Like in this case, the resistance of this resistor was supposed to be like a fuse, like 0 ohms, 0.39 ohms resistor, very low ohms resistor. I replaced with the, if you check from the video, I think I replaced at first with a high value around the 300 something ohms, and it did not work. And I come with a tweezer here. I short the resistor and the controller came back to life. So the value of this resistor was 0.39 ohms. It's very easy. You can go on Google and check R39 code resistor, SMD resistor, and you check the value. So I don't know where 221 ohms was coming from. Fine. So that I have cleared that issue of the resistor. Let's go to this problem. So what is the problem with this phone? Galaxy A20 charging error. Can you fix this phone? Let's open the phone just to apply some kind of heat on the bottom. Let's try to get inside this phone. We don't want to damage anything, so you have to be very careful by taking out the back cover. There's some kind of stuck with some glue. Okay. So now we need to take out all the screws and check what can be the fault here. What can be. Now let's take out the seam tray. Let's inject the seam tray. I never found a fault like that, but we have to fix this kind of fault. So what do we have here? That's the phone. That's the phone. We have the main board. We have the charging flex board here. So what I want to do, let's disconnect the battery here. Let's disconnect all the cables. We want to concentrate on this flex cable. So let's see what's going on here. Let's see that the charging flex board, we have the place for the connector here. The connector looks fine. And the charging port, charging port looks okay. What then is the story? What is the story here? Let's clean this board. But I know cleaning is not going to solve anything. Where's my alcohol? So, how do we treat such kind of jobs? Any idea how we can treat such kind of jobs? How do you deal with the charging error? So, you know what? These are some kind of jobs which are very tricky. When the charging port is good, the board looks fine. I don't think we have any shorted component here. If I'm to check, I don't think there's any shorted component. All the components looks okay. But this problem, I found it many times. And what was the problem? Most cases there's miscommunication, because on the charging port we have the plus and minus. The plus, which is driving 5 volts from the flex board to the main board, and we have some data lines. So if it happens that the data lines, they are not communication and there's an interruption between some charging data lines, it's very possible to have such kind of error. So let's do some trick. Let's do some tricks here. What we want to do, want this line. Let's do some tricks here. If we can do some tricks, and you need, what I'm doing here, I'm shorting all the data pins together, and we'll try to see if that can solve the problem. That's all what I'm doing here. I need to short all the data pins together, and then I'll test to see if that can give us results. Because there must be a reason why this is happening. Okay. Hopefully this will solve the problem. Because I found other models, when you do such kind of thing, it's very possible to have a working board again. We are coming with the jumper wire here to this data line. We are dealing with something very small. It's not easy. I'm dealing with a very tiny thing here. So this jumper should come here. And lastly, what I'm doing here, I'm just trying what I've done sometime before, and I found it working. But if you know where exactly this error is originating, I think you can leave a comment so that I will learn also how to deal with such kind of things, such kind of errors actually. So that's our jumper. Okay, we just short the data pin, charging data pins from here to here to here. So now we need to test. Let's test this to see if it's working. I'm curious to see if this is going to give us any positive result. And if you know a better way of how to solve this problem, please leave a comment and I'll try to answer you. Let's put this just to hold the flex cable. So that will test nicely. Let's see, charger plugged. And it's taking 1.4 amps. Check the current. 1.7 amps. And the phone is charging. Huh? We have 61%. And our phone is charging fine. We just have 1.6 amps. Huh? Explain that. Explain that. We no longer having the charging sign error. And the phone is already at 61% and is taking 1.6 amps. Initially, the phone was taking around the 499, 500 max and is going back to 17, 18 milliamps. Now the phone is taking 1.6 amps and is charging sign, and we no longer having the charging error sign. So if you have a Samsung Galaxy A20, that's how you treat the charging error sign. Just short the data pins for charging. You check the video where I showed the data pins, and you can bring back the phone to life. Yeah, it's charging. Now it's at 62 and it's still taking 1.6 amps. This some kind of current is very nice. You can see here on my USB power meter. You can't see, I think, due to reflection, but you can see everything is working fine. So yeah, that was the repair. It is now at 62%. So what can I say? Like, subscribe, don't forget to turn on the notification bell for future updates, and see you on the next game. Bye.